Hello friends. In the last session, we have discussed few concepts related to fundamentals of organic chemistry. That is, we had discussed in the last session about the pKa of acids, water bases, and the factors affecting the pKa values. In this session, we'll be discussing about the aromaticity. Let's take an example of benzene. Hope you know that benzene is a cyclic structure. Benzene is a cyclic compound. It is a planar molecule. It is a planar molecule and a cyclic compound in which the pi electrons are delocalized. That means the system is conjugated. What do you mean by conjugated? If there are alternates, single and double bonds, we call those systems as conjugated systems. So there is an alternate double and double bond, single bond, double bond, single bond, double bond. So such systems are called as conjugated. In conjugated system, the pi electron gets delocalized. Delocalized means they move all around. Okay. Now, so benzene is planar, cyclic, and the pi electron cloud is delocalized into the benzene ring. Okay, and benzene is particularly more stable. It is more stable. It is stable. The reason for this stability is the resonance energy. So the resonance energy of benzene is 16 kilocalories per mole. That means benzene stability is, that is the energy, the resonance energy of benzene is 36 kilocalories. Okay, so hence the benzene is unusually more stable. Most of the compounds with this delocalized electrons, have much smaller resonance energies. Compounds such as benzene with unusually large resonance energies are called as aromatic compounds. Okay, more the resonance energy, more will be the stability of that compound. That is, the conjugated systems where the delocalization takes place, such compounds have small resonance energies, but compounds like benzene generally have very high resonance energies. Such compounds are called aromatic compounds. So for a compound to be aromatic, it should fulfill a few criteria. The first criteria is the molecule should be cyclic. The molecule should be cyclic. Okay, and the molecule should have alternate double and single bonds. That is, it should be conjugated. It should be cyclic. It should be conjugated. Molecule should be planar. The molecule should be planar. So the condition for aromaticity is molecule should be cyclic. It should be conjugated. That means it should have alternate double and single bonds. Then the molecule should be planar. Okay. So if these are the cases, then it will have an uninterrupted cyclic cloud of pi electrons above and below the plane of the molecule. So for this delocalization to take place, or for a pi cloud to form, each atom in the ring must have a p orbital. See, molecule should be cyclic, it should be conjugated, it should be planar. Then what happens? There will be a delocalization taking place. So for delocalization to take place, each atom should have a p orbital, and the p orbital must be able to overlap with the p orbitals on the either side of it. Okay, so the condition for a molecule to be aromatic is, the first condition is, it must have uninterrupted cyclic cloud of pi electrons. It should have a cyclic cloud of pi electrons. If the molecule, if it has to have a cyclic cloud of pi electrons, the conditions are, it should be cyclic, it should be conjugated, the molecule should be planar, that is each atom should have a p orbital, and that p orbital should be in a position to overlap with the adjacent, the p orbitals on the either side. So then only there will be a delocalization. This is the first condition. It should have a cyclic pi electron cloud. The second condition is, it should satisfy Huckel's rule. What does the Huckel's rule says? Huckel's rule says that the planar cyclic compound to be aromatic, it should have 4n plus 2 pi electrons. So for a cyclic planar molecule to be aromatic, that means it should be cyclic, molecule should be planar, and the other condition is, it should have 4n plus 2 pi electrons. It should have 4n plus 2 pi electrons, where n is 0, 1, 2, 3, so on. That is, if n is equal to 0, it will be 4 into 0, so it will be 2 pi electrons. If n is equal to 1, 6 pi electrons. If n is equal to 2, 4 to the 8, 10 pi electrons. If n is equal to 3, 14 pi electrons. That means it should have 1 pair, 3 pair, 5 pair, and 7 pair. That means it should have odd pair of electrons. A molecule will be aromatic if it satisfies Huckel's rule, and Huckel's rule says that it should have 4n plus 2 pi rule. That n is equal to 0, 1, 2, 3, so on. Okay, so there are a few conditions for a molecule to be aromatic. That means it should be cyclic. Second one is, it should be planar molecule, so that there should be delocalization. And the third important rule is, it should follow the Huckel's rule. It should follow the Huckel's rule. That means it should have 4n plus 2 pi electrons. That means it should have odd pair of electrons, 1 pair, 3 pair, 5 pair, or 7 pair of electrons. Okay, let's take an example whether the molecule is aromatic or not. Let's take an example of benzene. Benzene is cyclic. It is planar. It is planar. Okay, that means there is delocalization. For delocalization, each atom should have 1 p orbital. Okay, if there is a carbon-carbon double bond, then the hybridization of that carbon is sp2. If the hybridization is sp2, then that carbon will have 1 unhybrid p orbital. So this carbon has 1 unhybrid p orbital, this has 1 unhybrid p orbital, all has 1 unhybrid p orbitals. Because if the hybridization is sp2 hybridization means 1s and 2 p orbital will combine, so another p orbital will remain unhybrid. So if the carbon is sp2 hybridized, that means each carbon has 1 unhybrid p orbital. That means this has 1 unhybrid p orbital. Since there is 1 unhybrid p orbital, so there will be a delocalization possible. So benzene is a cyclic, it is planar, delocalization is possible, and it follows Huckel's rule because it contains 3 pair electrons, 3 pair of electrons. That is 3 pair of pi electrons. Because see, 1 bond, 2 bond, and 3 bond. You know that when I say 1 bond, there will be 2 electrons. 2 electrons, 4 electrons, and 6 electrons. So it has 6 electrons or 3 pair of electrons. Hence it is aromatic. Okay, let us take another examples whether the molecules are aromatic or not. Okay, so the conditions are simple. We have this compound. It is cyclic. Yes, it is cyclic. Conjugated. Yes, it is conjugated. Double bond, single bond, double bond, single bond. Does it follows Huckel's rule? How many electrons it has? It has 4 pi electrons. That is 2 pair of electrons. So Huckel's rule says that it should have odd pair of electrons. It has even pair. So this is not aromatic in nature. Are we getting this? Now let's take this example. It's somewhat like this. Is it cyclic? Yes, it is cyclic. It is planar? No. Here the carbon is sp3 hybridized. So each carbon should have at least one unhybrid p orbital. To have unhybrid p orbital, it should be either sp2 hybridized or sp hybridized. sp3 hybridized means one s and all the three p are involved in hybridization. It does not have an unhybrid p orbital, so it will not be there. It is not aromatic. Okay. Let's take an example. Now, is it cyclic? Yes, it is cyclic. It is planar? Yes, it is planar. All the carbon atoms has one unhybrid p orbital because the hybridization of carbon is sp2. Okay, now let us see how many pi electrons it has. 2, 4, 6, 8, 10 pi electrons. So 10 pi electrons means 5 pair of electrons. So this compound is what? This compound is aromatic. Okay, so the such compounds which contains a benzene nucleus are called as benzenoid compounds. Benzenoid, we call them as benzenoid compounds. Let's take another example. This is naphthalene. This is naphthalene. Let's take another example. Okay, let's see this. Let us see whether this compound is aromatic or not. Is it cyclic? Yes, it is cyclic. There is a double bond sp2 hybridized, sp2, sp2. All has an unhybrid p orbital. How many pi electrons? 2, 4, 6, 10, 8, 10, 12, 14. How many electrons? 14 pi electrons. 14 pi electrons means 7 pair. It has 7 pair of electrons. Okay, so this is aromatic in nature. So what is the condition for aromaticity? The condition for aromaticity is it should be cyclic, the molecule should be planar, and it should follow Huckel's rule. Huckel's rule is it should have 4n plus 2 pi electrons. What are benzenoids? Compound containing a benzene ring are referred as benzenoids. Okay, thank you.